Ask My Instructor 2.5.25. In this problem we have a rational function, polynomial over polynomial, and we're asking what is the end behavior of the function. What happens as x gets very, very positive? What happens as x gets very, very negative? Are there any horizontal asymptotes? To look at the end behavior in the positive direction, we look for the limit as x goes to infinity of the rational function. Before trying to take the limit, we rewrite the rational expression. To rewrite the rational expression, we look at the degree of the denominator. The degree of the denominator is 5, so we will divide the top and the bottom by x to the 5. We're going to distribute the 1 over x to the 5 into the parentheses for both the top and the bottom. And when we do that, this is what we get. We now examine the behavior of the parts using the theorem that c over x to the n goes to 0 as x gets very, very large in a positive way. Now c is just a constant value and n is a positive integer. For example, 4 over x to the 4th, that is going to 0. This is not that complicated if you think about it. 4, the numerator is staying fixed. The denominator x to the 4th, that's getting larger and larger and larger. So it's be 4 over 100, 4 over 1,000, 4 over 1,000,000, 4 over 1,000,000,000. If you think about it, you can pretty quickly see that this theorem makes sense. Likewise, 2 over x to the 3, that is also going to 0. On the other hand, 16 is staying fixed. That 16 really doesn't care what x is doing. Now 39 times x, not divided by x, but times x, that's getting larger and larger. So x is getting larger and larger, so the product 39 times x, that's getting larger and larger. So the denominator is settling towards a non-zero number, 16, while the numerator grows without bound. The overall ratio is positive, and the numerator is getting larger and larger and larger while the denominator isn't. And so the overall effect is that the ratio is going to infinity, which means that it's becoming unbounded in a positive way. We use the same approach to find the limit as x goes to negative infinity. So we're asking what's the end behavior of the function going in the negative direction. Again, we divide the top and the bottom by x to the 5, which is the same as multiplying it by 1 over x to the 5. Then we just have to do the algebra. And the limit as x goes to negative infinity of some number over x to the n, that also is 0. So again, 4 over x to the 4th, that will be going to 0 as x gets very, very large in a negative way. And as will 2 over x to the 3, that will also go to 0. Again, 16 stays at 16. So the denominator is again settling to 16. Now 39x, now x, keep in mind, is negative, so 39 times x is negative. So the numerator is getting more and more negative. The denominator is getting closer and closer to 16, a non-zero number that's positive. The overall ratio is going to be negative. And so this time, instead of going to positive infinity, it's going to negative infinity, meaning it has unbounded behavior, but this time in the negative direction. So our rational function has the end behavior that it becomes arbitrarily large as x becomes arbitrarily large, and it becomes arbitrarily negative as x becomes arbitrarily negative. And there is no horizontal asymptote because the ratio did not settle into a fixed number. Take care and let me know if you have any questions.